Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Subject is EC3351 Control System, Unit 4, Concept of Stability Analysis. Here we are going to see the topic about relative stability. On completion of this video, students will be able to explain what is relative stability and explain what is the gain and phase margin. The relative stability indicates the lossiness of the system to the stable region. It is an introduction of strength of degree of stability. In time domain, the relative stability may be measured by relative settling times of each root of pass of root. The settling time is inversely proportional to the location of roots of characteristic equation. If the root is located far away from the imaginary axis, then the transient dies out forest off, and so the relative stability of the system will improve. In frequency domain, the relative stability of the system can be studied from the Nyquist plot. The relative stability of the system is given by closeness of the polar point plotted to -1 plus J0 point. As the polar plot gets closer to -1 plus J0 point, the system moves towards the instability. The relative stability in frequency domain are quantitatively measured in the terms of phase margin and gain margin. Consider J of omega, H of omega locus. Let this locus across the real axis at point A and unit circle drawn within the origin as a center cut this locus point B. If the gain of the system is increased, then the locus will shift upward and it may cross real axis at -1 plus J0 point. When the locus passes through -1 plus J0 point, then the gain will be 1 and gamma equal to 0. Hence the closeness of the G of J omega, H of J omega locus shown in figure at to the critical point -1 plus J0 can be measured in terms of intercept G of Ga and the angle gamma. The value of Ga and angle gamma are quantitative indications of relative stability. These values are used to define gain margin and phase margin as practical measures of relative stability. Now let us see say about gain margin and phase margin. Gain margin is a factor by which the system gain can be increased to drive the system to the verge of instability, that is gain margin in dB equal to -20 log Ga. The phase margin is defined as the account of additional phase lag at gain crossover frequency required to bring the system towards instability. Phase margin equal to gamma equal to 180 degree plus pi Gc, that is gain crossover frequency. Determine the gain crossover frequency, phase crossover frequency, gain margin and phase margin of the system with open loop transfer. So G of S equal to 1 by S into 1 plus 2S into S 1 plus S. The gain phase crossover frequency and gain margin we are going to find. So G of S equal to given function, you put S equal to J omega. So consider substitute S equal to J omega, so you will get this. From this consider omega Pc 1 minus 2 into omega Pc square equal to 0. From this find the omega Pc value 0.707 radians per seconds. So next one is we have to find gain margin, that is Kg equal to 1 by modulus of G of J omega at omega equal to omega Pc. So substitute all the value, you will get the Kg equal to 15. Next one, to find the gain, crossover frequency and phase margin. G of s equal to 1 by 1 plus 2s into 1 plus s, substitute s equal to j omega. Then find the angle, that is angle of g of j omega equal to minus 90 degree minus tan inverse of 2 omega minus tan inverse of omega. So the gain, crossover frequency modulus of g of j omega value will be 1. So solving these two equations, we will get the omega equal to 1 means we will get the gain magnitude value 0.3. Omega equal to 0.5 means magnitude value 1.26. Next, gain, crossover frequency. Find the gamma equal to 180 degree plus 5 GC, that is equal to 12 degree. The quiz questions are: define relative stability, what is phase margin and what is gain margin. Thank you.